Hello, this is Mr. Stansbury. I'm going to take you through the notes on direct variation. At the end of this, you should be able to say, I can show that two variables can be directly proportional, and I can find a formula connecting the variables. Okay, so two variables are directly proportional or very directly if multiplying one of the variables by a number results in the other one being multiplied by the same number. Okay, so if variables x and y are directly proportional, we write y varies directly as x, or y is directly proportional to x. Okay, if y varies directly with x, then y equals k times x, where k is a constant called the proportionality constant. Okay, when y is graphed against x, it's a linear graph that passes through the origin that has a slope k, and it's super important that you realize that it passes through the origin. If it doesn't pass through the origin, then it's not directly proportional. Okay, so let's take a look at example 1 here. For the table of values, plot the graph of y against x. So we're just going to graph these points here. So we get 2 and 5. 3 is at 7.5. Ooh, we're going up to 15. So let's make all these go by 2. So x is at 2, y is at 5, so that's right here. 3 and 7.5, right? So that's going to be, that's 10, that's 8, so here's 7, so 7.5 will be right about there. 4 is at 10. 5 is at 12.5, which is about right there. And then 6 is at 15. Okay, so let's see, that's 10, 14, that's about 15, right about there. So hopefully you can look at that and say, hey, that's going to make a nice straight line, isn't it? And it is going to make a nice straight line that just so happens to go right through the origin, and that's pretty important to know. That's what makes this a direct variation problem here. Okay, so these here, we've graphed our lines there. Okay, and then now determine whether y is directly proportional to x. If it is, find the proportionality constant. So they're basically saying, okay, yes, it makes a nice straight line that goes right through 0, so it's directly proportional. Okay, and then now we're going to find the proportionality constant, which we call k. All right. So really, I mean, like the quick and easy of this, the proportionality constant, that's just the slope of the line, right? So if we look at this, we start at 0, 0, and we go up. A nice little intersection is right here at the point 2, 5, right there. So the rise from 0, 0 up to 2, 5 is up 5 over 2. So it's up 5 over 2, which is 2.5, which is our proportionality constant. Okay, let's take a look at example 2 here. Suppose t varies directly with v and t equals 14 when v equals 9. Find the proportionality constant k. So if we have t varies directly with v, what we know is that t is going to equal our proportionality constant k times v. Okay, so really if we're looking for k, we divide both sides by v. And we know that our proportionality constant, when we have direct variation, is going to be t over v. And this t is always going to be the first part. That's going to be the top. So whatever comes first here is going to be our numerator. And then whatever it varies directly with v is going to be in the denominator. So in this case, it's going to be t is 14, v is 9. So if we take 14 divided by 9, we get that k equals 1.56 would be our proportionality constant. Okay, let's take a look at the second part of this. We're going to take a look at these examples here to help us understand, but before we do that, we're going to do a quick little comedy break. let's take a look at this. Example 2, suppose t varies directly with v and t equals 14 when v equals 9. So I've found this. I'm going to show you this little system here where we just go through and we make a chart for these things here. Let's do this in blue. Sorry, we're making a chart here. And when we make this little chart, it's just going to help. This chart type system here is going to work all throughout this entire chapter. So let's do this. So suppose t varies directly with v. Doesn't matter which one goes where. We're just going to put them in there. And here's what we're going to do. We know that when t equals 14, v is going to equal 9. Okay. Now it says find v when t equals 40. Okay. So if this thing here is directly proportional, as it says it is right here, then the easiest way we can figure out what v is going to be is just do this little cross products thing. So if we've got directly proportional, we know that 9 times 40 is going to equal 14 times v. So 9 times 40 equals 14 v. So 9 times 40 is 360. That equals 14v. So if we divide both sides by 14, that'll tell us what v is going to be. Instead of having to go through and multiply, figure out what you have to multiply 14 by to get to 40 and all that kind of stuff, we can just go quickly to figure that out by doing our cross multiplying. Okay? So if we take 360 and divide it by 14, we get 25.7. Okay, so we now know that when, let's just do this, we now know if t varies directly with v, and we got 9 is to 14, and we get 40, we can figure out what this v is, and that's 25.7. Okay? Okay, so now let's find t when v equals 30. So we'll do the same thing. We're just going to set ourselves up a same little chart here. v, t. We know, again, that when t is 14, v is 9. Now it's asking us, what's going to happen when v is 30? And we got to figure out what t equals, right? So, same exact process, 13, just do cross products here, 30 times 14. Oh boy, slow down, take your time, there we go, 30 times 14 equals 9t. Okay, so let's just go through and do 30 times 14, and that gives us 420. That equals 9t, so divide both sides by 9, and that should tell us what t equals. So divide that by 9, and we get 46.67, so we'll call it 46.7 is what t equals. Okay, and that will work every time when you're doing our proportionality here. Sorry, our direct proportionality or direct variation here. Okay? All right, if you have any further questions on this, please feel free to ask in class. Thanks.